Schools from as far away as Louisiana, Oklahoma, Arkansas, Mississippi, and Alabama come to compete. This year's host band is none other than the Golden Bears Marching Band from South Oak Cliff High School.
We're extremely excited to be the host for the Battle of the Band. This has been many years. This is exciting for the girls, it's exciting for the crowd, so we're going to have a good time today.
With me, at the Battle of the Band, it's just fun to be there out there doing what you love to do, and that's march.
That's Majorette, Division 2. Carter High School.
Well, as you can see, these guys have what it takes to compete against the best. For School Zone Dallas, I'm Alfonso.
Hey, what's going on, you guys? My name is Daryl, and we're where it all happens, behind the scenes in the control room of the Algebra Dudes. Thanks for tuning in for today's show, and we're ready to go ahead and get started. But first, we just want to go ahead and cover a few ground rules. So let's head over to my man Ivan for more.
Okay, good luck on your problem. Okay, ground rules. Let's see. Number 1. You have to call in. Pick up the phone, give us a call, give us a ring. I mean, we really get awfully bored sitting around here doing nothing. So give us a call. The number is 972-925-3123. Take a picture, write it down, just give us a call.
Number 2, when you do call in, step away from the television. It really hurts our ears and it sends off a really bad tone. See what I mean? So, when you call in, step away from the television. I thank you, our host thank you, and our ears definitely thank you. And another thing, when calling into the show, please do not use cell phones. Cell phones do not work too well with our audio system here in the studio. They give off a really bad signal and we have a hard time hearing what you're saying. So remember, no cell phones. Another thing that we want all of you out there watching to know is that you could be on TV. That's right, your face could be on the tube. Send us a picture, whether it be an individual photo or a photo of your entire class. We'd love to see you, and so would everyone else out there watching. Either mail it to us through interdepartmental mail at DISD Box 379 or drop us a line at algebradudes@dallasisd.org. Well, it looks like it's just about time for the show to get started, so I have to say goodbye. But don't forget to call in for your chance to win all sorts of cool prizes. So get set for an all-new edition of the Algebra Dudes.
Hey everyone, and welcome to the Algebra Dudes. I'm Reginald Samuel, math coach for the Dallas Independent School District.
I'm Nadia Ayala, algebra teacher at WT Park High School. It's great to be here with you guys.
Yes, it is.
Now, a lucky caller will win a great gift today, so good luck, caller. And what's the gift?
Okay, let's check out the gift. Okay, the number to dial is 972-925-3123. Okay, before we go ahead and get started, let's look at what the gift is. Oh my God, painless algebra. Algebra has been so painful. This is painless algebra. Make sure you get it. And none other than when you and your friends go somewhere and have a good time, you can capture it all on the camera. Okay, so we have a camera and we have
painless algebra.
The painless algebra. All right. So let's start calling. I know we have a caller from Spruce. Caller, are you there?
Yes,
How are you today, dear?
fine.
Good to hear from you. Good to hear from you. Tell Miss Terrell to thank you for staying afterwards. And thank all of the students for staying afterwards.
We love you.
Aw.
Oh, I love you all too. I love you all too. Okay, you ready to work a problem?
Yes.
Let's go to the problem. Okay, the problem reads. Can you see it?
Yes.
Okay, here we go. The total charge for a taxi ride that Eric took was $13.65. Okay, he wants to leave a 15% tip. About how much will he pay in total for the taxi ride? So let's go to work. Tell us what we need to do.
Okay, so if we're leaving a 15% tip and the total's 13.65, what do I do with those two numbers?
Multiply.
Multiply them. Okay, so here's the deal though. 15%, I can't multiply it by 15%. What do you need to do with the...
Make it a decimal.
Cool. So I'm going to put 13.65. And you said multiply?
Yes.
Okay, so we're going to go ahead and multiply it by how much?
0.15.
0.15. Awesome. Okay, so do you have a calculator with you?
Hold on.
Okay, I can do this here. You can follow me if you want to here.
Okay.
Okay, so how much was that? 13.65. So 13.65 times how much again?
0.15.
0.15. So then I'm going to press enter. Okay, so more or less, if I want you to round it to the nearest penny. So it would be $2 and about
5 cents.
5 cents. Okay, cool. So what do I need to do with the $2 and the 5 cents now?
Add it.
Now I have to add it to, so I'm going to put $2 and 5 cents, and I'm going to add how much?
13.65.
So my final answer is
$15.70.
$15.70. Let's see if let me go ahead and write this down. Approximately we got $2 and 5 cents, and then we went ahead and we added 13.65. So our total was $15.70. So let's
deal.
see if it's in our answer.
Oh, let's see.
Yay, we did it right. What's my answer?
C.
Letter C.
Good job. Excellent job.
Good job. Are we real far away?
All righty. Timothy from Atwell, are you there?
Yeah.
How are you, Timothy?
Fine.
Sounds good. Sounds good.
Are you asleep?
No.
No.
No, I'm awake. Just give me my problem. You ready for your problem?
Yeah.
All righty. Here we go, buddy.
So I'm trying to throw text problems at you guys so you can go back.
All righty.
Review. Okay, now we've got some kind of spinner, so let me just zoom in on the question, okay?
All righty. The question reads, what is the probability that the spinner shown will land on a number greater than 4? So we're talking about numbers greater than 4.
Okay, so let me circle all the numbers that are greater than 4. Can you tell me which ones?
Hold on just a minute.
Okay.
The PA system is going on.
All right.
Okay, can you tell me which numbers are greater than 4? Am I gonna pick 4?
5, 6, 7, 8, 9.
There you go. 5, 6, 7, 8, 9, and 10. So how many numbers are those?
6.
6. So I'm gonna come up with a ratio here. It's gonna be 6 out of, what's the total?
10.
6 out of 10. So 6 out of 10 will give me a decimal, right?
Yeah.
It'll give me
60.
0.60. So to change it to a percent, I just have to move the decimal
2 over 2.
over 2. So my final answer is 60%.
Percent.
And it is going to be
my
letter
C.
That was too easy for this guy.
I know.
Excellent job, Timothy.
Genius.
You are a genius, buddy. Hey, I tell you what, you make sure you keep calling in.
All right.
All right, have a good one.
Uh-oh.
Okay.
We should have
We were just informed that we need you all to call
I need to call in. Don't be scared. Don't be shy.
All righty, now we have, and I know someone has already picked up the phone and dialed the number, so we're going to listen to our little earbuds and hear who called, who just called. They said.
Okay, well, let's go ahead. While we wait, I'm going to go ahead and start another problem.
Okay, sounds good.
Is that good?
That sounds good.
All right, let's see. Oh, I hear a phone call. I think we need a grid for this one. Just set up your proportion. Are you laughing at me, sir?
Yes, ma'am. Yes, ma'am, I am.
Oh.
Okay, here we go. All right, Kiana from Atwell. Kiana, are you there?
Good.
Hi, Kiana.
Hi.
How are you?
I'm fine.
Sounds good. We are jamming to the tunes of a different drum.
Are you
or
hearing
something.
music? Is she hearing music? There it is.
Kiana, can you hear music?
No.
Okay, here we go. To my right. Your turn. They're talking. I'm sorry. They're talking to us in our ear. Okay, now. Can you see the two rectangles right here?
Yes.
Okay, let's read the question now. Okay, go ahead, Mr. Samuel.
Thank you so much, dear. The problem reads, the two rectangles shown are similar. And I'm going to wait for a second because the PA system is going on. Okay, here we go. The two rectangles shown are similar. All right, using the dimensions given, find the length of the side labeled X. So there we go. Similar.
Okay. Now, anytime two shapes are similar, you set up a proportion. Did you know that?
Yes.
Okay, cool. So I'm going to set up a proportion, and you set it up however you want. You can do the side over the bottom equals the side over the bottom, or the side over the side equals the bottom over the, however you want to do it, okay?
Okay.
So can you set it up for me?
Side over bottom equals 14 over 20.
Good. So you're doing the side over the bottom equals,
Side over bottom.
which is going to be what?
X over 12.
Awesome. Now what's the next step to do?
Cross multiply.
Cross multiply. And I always like to start with my X. So what's 20 times X?
20.
20x equals, and now let's do 14 times 12.
168.
Good. 168. And then what do I do from there?
Divide by 20.
So divided by 20. Okay, what is my X equal?
8.4.
6.
X equals 8.4.
8.4.
Sounds good.
Okay. So my final, now I'm going to look at my answer choices. Let's see. What is my answer?
A.
Letter A, yay. Was that hard?
No.
Good. So you're going to pass tax, huh?
Yes.
Awesome.
Sounds good. Sounds good.
Okay, let me put little ears. Oh, this little girl. And she's got big feet. She's going to say hi to you. There you go. Scary looking thing.
Yeah, that is
Colleen.
that's the scary face.
It's a scary face. Asia?
Asia, how are you, dear?
Fine.
Hi. Oh, good to hear from you. Good to hear from you. Are you ready to work a problem, Asia?
Huh?
Are you ready to work a problem?
Yes.
Sounds like a winner.
Do you want a hard problem or an easy problem?
I want an easy problem.
Oh,
Okay.
this one is very easy.
You think so?
Yeah, I think it is very easy.
All right,
Easy, hard, easy.
He didn't pick an easy one for you.
This is an easy problem.
Okay.
You'll get it without any questions. Here we go. Are you ready? The problem reads, the quadrilateral in the graph shown is to be dilated by a scale factor of 4. Which graph shows this transformation?
Okay, scale factor. What are we supposed to do with the scale factor?
Multiply.
Good. We're going to multiply. So I'm going to go here, and I'm going to get each one and multiply it by
4.
By 4. Good. Okay, so my first ordered pair, this one's, what's the ordered pair here?
it say?
What's the ordered pair right here?
0
0,
plus
0, 2. Awesome. 0, 2. Okay, what's my ordered pair right here?
1, negative 1, 1.
Oh, it's on the right.
1,
1,
0.
0. Awesome. And then what's my ordered pair over here?
Negative 1,
Negative 1 and
negative 1.
awesome. And then my last ordered pair here would be
Negative 2
negative 2
and 1.
and 1. So what am I supposed to do to each number because my scale factor is 4?
Supposed to multiply by 4.
Awesome. So
Good
can
job.
you give me my new, multiply this by 4 by 4. So what's my new ordered pair? 0 times 4?
4. 0.
0, and I was going to write down 4. What's 2 times 4?
8.
8. Awesome. So 0, 8. Okay, so over here, multiply by 4 by 4. So what's my new ordered pair over here?
4, 0.
So 4 and 0. Okay, times 4 times 4. What's my new ordered pair?
4, 4.
4.
Oh, negative 4.
There you go. And then times 4 times 4. What's my new ordered pair?
8 and 4. Negative 8 and
There you go. Negative 8 and
4.
4. So does my quadrilateral get bigger or does it get smaller?
It got bigger.
It got bigger. So here we go. I'm going to show you the answer choices, okay?
Okay.
So let me zoom out. So you said it got bigger. So which one can I automatically eliminate because it didn't get bigger?
You can eliminate B.
Letter B. Good.
deal.
So let me give you the answers. One of your ordered pairs was negative 8 and 4. The other was 0, 8. Your other answer was negative 4, negative 4, and then 4, 0. So those were your answers. Can you more or less try to see which one?
A.
Okay, let's look for 0, 8, this, or 4, 0. 0, 8. Let's look at letter A first. Woo. Okay, does this one have 0, 8?
No.
No, this one says 0, 4, right? So it's not this one. And we said it was in B. Here we go. Does this one have 0, 8?
No.
That one is 4, 5, what?
6.
6. This one's 0, 6. So I guess my answer is going to be
D.
letter D. There it is, 0, 8. Was that hard?
No.
Awesome.
Thank you.
Yay. No smiley face because they changed the screen.
They were
Yay.
scared.
See, I had time to do my smiley face then.
Okay.
Yay.
Yay, Avante.
Avante, hi.
Hi.
How are you?
Fine.
Sounds good. Sounds
Are you
good.
an easy problem or a hard problem?
Easy problem.
An easy problem.
Not
Okay.
just one easy.
Yeah.
Easy.
Two. Okay, one
Yeah.
easy.
Because a negative times a negative gave us a which is a positive.
Are you okay?
I am wonderful.
Are you sure? I'm looking for an easy problem for you, okay?
Orthogonal and isometric views are very easy.
Similar?
These
They
are
want the
very easy.
volume.
Oh, they want the volume of that?
Yeah.
Oh, that's not hard.
Okay.
Okay, we're gonna do this one.
Like my students say, is that hard for you? Okay, here we go.
Okay, the problem reads, these trapezoids are similar, okay? What is the value of A?
Value of A. So we heard you. Okay. Here we go. Let me see. Can you see the letter A right here?
Okay.
Okay, this is the one that we're looking for. So if they're similar, just like with the one we did earlier, anything with similar, we can set up a what?
Proportion.
Awesome, a proportion. So you pick up a ratio, you make up whatever ratio you want for this figure and for this figure, okay? There's a lot of numbers, so you choose whatever you want to do, but make sure you include the letter A in there, okay? So,
Okay, I need to see the smaller one.
okay, here we go. Ooh,
Okay.
there you are. So this is the A on the other one, okay?
Okay.
So how would you set it up?
Okay, A over 24 equals 14 over 16.
Okay, so you did A over 24. So you're doing like the height over from L to K. So A over 24 equals, you have to do the same thing over here. So you're going to do 14
Over 16.
Awesome. That's
Excellent
perfect,
job.
Perfect. Here
Excellent
we
job.
go. Perfect. Now, I always like to start from the variable. So what's A times 16?
16A.
16A equals, let's do 24 times 14.
Okay.
24 times 14. Do you have a
336.
Awesome, 336. And then from there, I want the A to be by itself. So what do?
You would divide by 16 and that would cancel.
Great job.
Good
So
job.
my final answer is A equals
21.
Yay!
Good job.
Good. It looked kind of funky at first, but it was pretty easy. Yeah.
Yeah. Oh, that's cute. Let me see.
There you go. Yay! That one didn't look scary.
That's Curious George's cousin.
Whose cousin?
Curious George.
Oh, okay. Bye.
Bye. Well, keep calling back. And we have Octavia from Spruce. Octavia, are you there?
Yes.
Hi, Octavia.
Hi.
Octavia,
Huh?
we are going to go ahead and get the problem done. You ready for it?
Yes.
Let's go to work.
I didn't get it. Okay, here we
Okay,
go.
let's look
You want a
at
hard one, an easy one, or a medium one?
Medium.
Medium.
I think that's a good problem.
This is a medium?
That's a medium.
It's a medium hard. Okay. Woo. Word. Okay. You see the
Okay.
cubes here? Have you played with the cubes before, Octavia? Okay, cool. So there are the cubes, and then Mr. Salmi is going to read for us.
Okay, let me get my reading voice together. The problem reads, this solid figure is built with cubes. Okay, how many individual cubes are visible in the top of the, in the top of this solid?
In the top view of the solid.
I was looking for volume because you said that
Okay,
this is a
no,
volume
I just
problem.
said for
I got all messed up, but yeah, top view of this
this isn't
solid.
even medium hard. This is easy.
Yeah, this is really
We need
easy.
to give you this easy one. But here we go. Now all we're going to do, we're going to count the cubes that are visible at the top. Okay, so just think about the top. So you want to start numbering them? Okay, I'm going to start numbering them, okay? Only the ones at the top. So I've got
1, 2, 3, 4, 5, 6, 7, 8, 9.
well, that was too easy.
See?
Are you sure it's not 8? Yay!
Good job.
Woo. Big smiley face.
Thank you.
You're welcome.
So welcome. Good job. Good job. Okay.
Bye-bye.
That was good.
That was real easy.
Yeah.
She said
I was
medium
looking for the
hard.
volume. I was like, I stopped reading because I was like, that didn't ask for the volume. I'm sorry.
David?
All righty. David from Atwell.
David?
Hi.
How you doing?
Fine.
Fine?
Sounds good.
You sound fine.
Are you ready to work the problem, David? Let's go to work, David.
What's your request? Medium, hard, easy?
Easy.
Easy? Well, that was easy. I just gave up the easy one. Okay. The length, find the area. We'll do this. Here we go.
Okay, that is an easy one. Okay, here we go. The length of a rectangle is 4x plus 1, and the width is 2x plus 5. Find the area of the rectangle.
Okay, we've got a rectangle. And the length is, it doesn't really matter which one you pick to be length, but I'll just say this is 4x plus 1, and this is going to be 2x plus 5. So when we're talking about area, I want the inside. So how do we get the inside? What's the formula for area?
Multiply.
Area equals, good. Can you tell me the length
times width.
times width? So I'm going to plug in what I know. Area equals, what's your length?
4.
Go for it.
4x plus 1.
And what's your width?
2x plus 5.
Awesome. Okay, so I don't know how your teacher taught you. If she taught you FOIL or to distribute, or there's a box method also. Do you happen to know which one?
Box method.
The box method. So you like to draw the little box? Cool. So you are a visual learner. That's awesome. Here we go. I'm going to draw my little box. And at the very top, I'm going to put 4x plus 1. Is that what you did?
Yes.
And I'm going to put 2x and then my positive 5. So let me zoom in on the box. Okay, so let's multiply. What's 2x times 4x?
8x
8x.
squared.
Awesome. Now 2x times 1.
2x
Awesome. And then I'm going to go on to my 5, right? What's 5 times 4x?
20x
20x. Good. And then what's 5 times 1?
5.
5. Then what do I do from there? What do I do with my like terms?
Combine.
Combine them. Good. So my final answer is
8x squared plus 22x plus 5.
awesome. That's fine. Was that easy after all?
Yes.
Yay!
That was a good problem. That was an excellent problem.
You
Excellent
did
job,
it.
David.
Thank you.
Great job, David. Yay! Woohoo!
David.
David.
All right,
Thank you, David.
Atwell and Spruce, keep calling in. We're going to see who gets the most calls.
Ooh, let's see.
And the rest of the schools out there, we need to hear from you.
Colin.
All righty, and our next call.
Ow.
Here we go. Hey, Kiana, how are you, dear?
How are you doing?
I am well. It's good to hear from you.
Good to hear from you too.
All right, are you ready to work your next problem?
I sure am.
Okay, sounds good. Let's look at, that looks like a really good problem. I like that problem. Let's give her that problem.
Okay. We're going to make you think a little bit, okay?
Oh no.
Oh, I promise it'll be fine. Here we go.
Okay, here we go. The problem reads, when the following net is folded along the dashed lines, the result will be a rectangular prism. What is the surface area of the rectangular prism?
Do you know what a rectangular prism looks like?
Yes.
It looks like a what?
A rectangular prism?
Yes.
Like a box.
Like a
Looks
box,
like a
like
box.
a cereal
Good
box,
job.
right? Okay, so when we're talking about surface area, it's kind of like when you wrap a gift. The wrapping paper would be the surface area. We don't care about the inside, we just care about the outside, okay?
Okay.
Okay, so this is what we did. It's kind of like we opened up the cereal box and we laid it all out. So I'm going to get each one individually and I'm going to find the area for each one. Is that cool with you?
Yes.
That's
Okay,
cool
so
with me.
they're all rectangles, right?
Uh-huh.
So rectangles are length times width. Do you agree?
Yes.
Okay, cool. So here we go. Let's do length times width for this one. So length times width here would be length times width. So this would be 10.
10 times 10.
How much?
So 10 times 3.
10 times 3. So this rectangle here, what's the area here?
30.
This would be 30. Good. Here we go. Now this one's a little bit bigger. So you know it's not going to be 30. It'll probably be a little bit more, right? So my length is what right here?
10.
10. Because this is 10, this is also going to be 10, right?
Uh-huh.
So if this is 10, check this out. What is going to be my
5.
5? So I'm going to set up the problem for me.
10 times 5.
10 times 5. So that gives me
50.
awesome. Yeah, you're right.
Yeah, 50.
So that gives me 50. This is 30. Okay, here we go. Let's go do, let's go ahead and do this one for now. Okay. So what's this length right here?
3.
Okay, this is 3 and we already got 5 here. So how do I set up my area here?
3 times 5.
3 times 5 gives me
15.
15. You see, isn't it easy after all? Awesome. Okay, here we go. What's my length right here?
10.
Okay, this is 10, and then let me let you see over here. 10
3.
times.
It's 3.
Okay, so I'm going to do 10 times 3 gives me
30.
30. So this is the same thing as up here, huh?
Uh-huh.
Okay, cool. Now What do you think this one's gonna be?
50.
50. It kind of looks the same, but let's double check. So what's my length right here?
It'll be 10.
This is 10, and this is going to be
5.
5. So 10 times 5 will give me
50.
50. And over here, last one, this is going to be what?
3 times 5.
So 3 times 5 gives me
15.
What do you think I'm going to do with all my answers?
Add them together.
I'm going to add them all up. So let's do, here we go. I'm going to get my calculator, okay?
Okay.
So my first one was 30, so I'm going to get 30 plus 50 plus 30 plus 50 plus 15 plus 15. So my final answer is going to be
190.
190.
Centimeter
good.
square.
Awesome.
Centimeters squared. Good job.
I love how you said that. So this is going to be 190. I love how you said centimeters squared because we're talking about area. Yay! Was it hard after all?
No.
It looked kind of funky at first, huh?
Yep. Can I get a smiley face?
Of course. You want a funky one? Let's see. Let's make them a little funky. All right. And a big smile. Let's see. Let's give them bushy eyebrows. Big ears? You want some big ears?
Really, really big ears.
Okay. Really. Ooh, this looks. Yay. And let's make them skinny. There you go. You're welcome.
Good job. Wonderful job.
She was about to.
Okay, and Timothy, I guess, hung up. Timothy, give us a call back.
Call us back. Timothy?
Timothy? Oh, hey, Timothy, how are you?
We thought you hung up on us.
Yeah, we did. You ready to work a problem, Timothy?
Yeah.
Sounds like a winner.
So, easy, medium, or hard?
Back to work. Back to work. Everybody.
Okay,
Work,
good.
work, work,
At least you
work,
said
work.
easy, right?
Yeah, exactly. That looks pretty good. Yeah. That's a good problem. That's a good problem. No, actually, it's a really good problem because a lot of the students that I dealt with, I don't think they got this problem right until after we worked it out. Okay, here we are, Timothy. The problem reads, suppose a can of paint covers 48 square feet of area, okay? Matter of fact, this is very simple. How many cans of paint would be required to paint the entire basketball key?
Are you ready? Okay, so we know 1 can of paint is going to cover 48 square feet, right?
Yeah.
So first we have to find out what the total square feet is here, so then we can find out how many cans we need, right? So what 2 different shapes do you see here?
A square.
You see a square, well,
A semicircle.
and a circle, yeah. It looks like a square, but the lengths are not the same, so it would be a rectangle, huh? So a semicircle, awesome. So if you look in your formula chart, let's go ahead and do a circle first. Area of a circle
Pi
equals pi, good.
times pi squared times
Pi
pi
r,
radius times square.
good. Pi r squared, right?
Yeah.
And then what am I going to do to my answer?
Say it again.
Once I plug in my numbers, I still need to do what?
Divide by 2.
Divided by 2 because it's not a whole circle, huh? So at the end, I'm going to divide it by 2. So here we go. They don't give me the radius, but what do they give me here? What is this called?
3.14.
Hold on.
Oh, diameter.
The diameter, right? So this is 12. If this is 12 and it's 12 up here, what's my radius?
6.
Awesome. What did you do with 12?
Divided.
You cut it in half, didn't you? So this is going to be 6. So let's plug in what we know. I have, did they want us to put 3 point? No, they weren't specific. So I'm going to leave pi there. If you notice your calculators have a pi sign in there, so you don't have to put 3.14.
Exactly, and it's definitely recommended to use that pi if they do not tell you in the problem to use 3.144 pi.
Okay, so I've got pi and my radius, like you said, was 6, so I plugged it in, and then I'm going to divide my answer by 2. So let me get my calculator so you can tell me what to plug in, okay?
Alright.
Okay, now, do you all use the graphing calculators, right? Okay, you see the pi sign right here?
Yeah.
So what do I need to press to put the pi sign?
Just second.
Second, because it's in yellow, and
the carrot button.
The little, me too, I
Yep.
call it the carrot
The
button
carrot
too.
top. Mhm.
Okay, here we go. And then, I probably got it from you. And then, here we go. I'm going to open my parentheses exactly how we saw it, and I'm going to put 6 squared, and then what do I do with my answer?
Multiply, divide by 2.
And then divided by 2.
15.
Okay.
18.
Uh-oh. You know what? I know what to do. I should have done the numerator first. And then do what? No, it still gives me the same answer.
Yeah, it's just, that's
No,
the
that was
correct
okay.
answer.
That was okay. So it's okay. Do you know why you got 18 though? You said something about 18.
No, yeah.
Okay. Did you get the answer I got though?
Uh-huh.
Okay, cool.
Okay,
So
maybe we did it
approximately
square.
it's going to be 50,
57.
57 approximately. Okay, so I'm going to go ahead and round up. So let me zoom out. So the area of my circle is approximately going to be 57.
57.
Okay, now I have to figure out what. I just have the top part, right? Now I have to figure out what.
12 times 19.
Awesome. 12 times 19. So 12 times 19 will give me how much?
228.
228. Okay, 228. So what do I do with 228 and 57?
Add them.
I'm going to add them. So let's add 57. So when I add 57, we end up with
85.
Awesome, 285. So over here, I'm going to put 285.
Divided by 2. Oh.
Okay, divided by how much?
Never mind.
Hold on. This is how much square footage I have, right?
That's how
Okay,
much.
that's how much I have. So,
Divided by 48.
awesome, because 1 can gives you 48, so I have to divide by 48. So when I divide that by 48, how many cans am I going to use? Approximately
6.
Approximately 6. Because it gives you about 5.9, so approximately 6. So my answer's letter,
B.
you did pretty good.
That's
This-
a wonderful job.
Yeah, this is probably an objective 10,
Alright.
maybe?
This is objective 8.
Objective 8?
Well, it's objective T as well because it's
Yeah,
a real life
it's a multi-
application.
yeah. Okay, thank you. You did awesome.
Wonderful job.
Woohoo!
Yeah.
That was good. That was probably 10, huh? Because there's a lot of steps.
Yeah, but
And it could be 8, too.
yeah. Tim-
Hi, Timothy.
Timothy, hey, Timothy.
Timothy's back.
Timothy.
Hi.
Hi.
Hold on, Timothy. You don't sound too Timothy-ish.
My name's not Timothy.
I
My name is
know.
Brandisha.
Okay.
Your name is, say it again,
Brandisha.
Brandisha. We apologize.
She did not sound like Timothy.
Yeah,
Timothy who called her
Brandisha,
this.
yeah, you were just, the voice was a little too soft.
I'm from Spruce.
Okay. Oh,
They
okay.
switched the phones. We heard.
Okay.
Okay.
Brandisha, you ready for the problem?
Yes.
What level of
Sounds good.
difficulty would you like?
Not too hard, but in the middle.
In the middle.
Okay.
Okay. Let me look for in the
I
middle.
always call it about medium. Yeah.
Uh-huh.
Yeah. So not too hard, not too soft. Just right. Okay, here we go. What are the roots of the quadratic equation y equals x squared minus 5x plus 4?
Okay. Now let me look at the keyword roots. Can you give me another word for roots?
Another word for root.
Yes. What exactly do they want to know?
X
The x something.
intercept.
Good. They want the x-intercept. Or sometimes they also say zeros. Have you heard of zeros? Yeah, sometimes they ask for the zeros or the x-intercept, so they'll just say, what is the solution? Okay? So here we go. Now, I'm going to let you decide how, this is tax, so I'm going to let you decide however you think you do it on tax. If you got this question, you can do it by graphing. Would you factor? Would you look at the table? You let me know. How would you figure out what the x-intercepts would be?
On the table?
On the table. Awesome. So you want me to go ahead and put this in under y equals?
Yes.
Okay, cool. Here we go. So here we go. So I'm going to go to y equals, and I'm going to type x squared
minus 5x
Good.
plus 4
Awesome. And then how do I get to the table?
second
Second.
and graph.
And then graph. Okay, so for my x-intercepts, what are your y's always equal?
0.
0. So
Good
I'm
job.
going to look for a 0 there. There's 1. So one x-intercept would be what?
1.
1. And I'm going to keep going down. Oh, there's the other 0. That's why they're called zeros also. That would be
4.
So 1 and 4. Good. So 1 and 4. Let me zoom out, zoom out, zoom out. 1 and 4. So this is, I would have my students, they have to show work. My students just can't circle the answer. They would tell me they went to y equals, and then you went to second table, right? And then you looked at the table. So on the table you saw
4 and 1.
You saw 1 0
No, 1
and 4
4 0.
Good. This is the kind of work that they would have to show me. Okay. So the answer is letter
D.
Letter D.
That's a good job. I like the way you show your students to show their work. Excellent job, Brandisha.
Thank you.
Pointy little. Yay.
Alrighty, our next caller is Avante. Avante from Adwell, are you there?
Yes.
Sounds good. Sounds good.
Hello.
Are
Sounds
you
good.
ready?
Yes.
Yes. Good. You want small, medium, or hard? Small, medium.
Medium.
Let's go
I'm
with
thinking
medium.
of food. Okay. What did she say?
She said medium. Mhm.
Let me see. Let's remind ourselves. I'm hearing deaf. I'm hearing deaf. Okay.
Okay, here we
I'm going
go.
a little slow today. Here we go.
Which expression is equivalent to x or 3x to the negative second power y, all raised to the third power, times 2x to the seventh y squared?
Whoa.
Okay, I wanted to remind you how to do the exponents because you'll probably get about 2 problems on tax. Oh, maybe, I don't even know. Okay, here we go. Now, when you have a little number hanging out outside the parentheses, do you know what you're supposed to do with the exponents?
What did you say?
She may not be able to hear you because the PA selection.
Oh.
Yeah.
Okay, when you have a little number hanging out outside the parentheses, what are you supposed to do with the powers, with the exponents?
Multiply.
Multiply.
Good
Awesome.
job.
So if the 3 has an understood power of, if you don't see a power on the 3, it's understood to be what?
3 to the power of 3.
No. 3 has a power, don't look at this right now.
Oh, okay.
The 3 has an understood power of?
1.
Of 1, awesome. And the y has an understood power of?
1.
1. Here we go. So here it's kind of like distributing, huh?
Yes.
We're distributing, so I'm going to get 3 to what power?
3.
To the third, awesome. X to what power?
Negative 6.
Good. And then y to what power?
Y to the power of 3.
To the power of 3. Awesome. And I'm going to go ahead and bring down what's left, okay?
Okay.
Here we go. Now, I can simplify 3 to the third if I want to. So instead of 3 to the third, I would have what?
27.
27. So I'm just going to, instead of me having to write everything again, I'll just put a 27 right here. Is that cool with you?
Yes.
Okay, so there's no more 3 to the third. Now, what am I going to do with 27 and the 2?
Multiply them.
Awesome. What's 27 times 2?
54.
Okay, so I'm going to end up with 54. Now, what do I do with my exponents when we're multiplying?
Add them together.
Add them. So what would be negative 6 plus 7?
And it equals 1.
X to the first power, right? And then 3 plus 2?
It's 5.
My final answer is...
Oh, it's A. Oh, B. No, wait. Oh, D. Oh.
That's okay.
Good job. Good job.
I wasn't looking.
Good job.
Excellent job. Okay, here we go. We have Aisha from Spruce.
Second time she calls. Woohoo!
Hi, I'm again.
Yay.
Hey, sounds good. I'm again.
I'm again.
I'm gonna do another problem. So
He's making fun of you.
no, I am
Yes.
I
not.
love him too.
Hey.
Oh, behave.
Okay, here we go. We are ready
Okay.
for our next problem.
Level of difficulty, ma'am?
Yeah.
What would you like?
Parameter.
Perimeter?
Some hard.
Oh,
Some
something
hard.
hard. Oh, I was surprised. I think I have perimeter in here. Oh, let me see. She wants something hard. I'm gonna give her something hard. Nah, that's too easy.
Let's see if she remembers this.
You think so?
Yeah. I mean, it's not
It's
too
not
hard.
You know what? Which one's hard? Over here.
Which one?
This
That one. That one.
That one. Kind of hard, not really, but okay.
Yeah, well, yes.
Because I'm giving them. Ready, ready? Here we go.
Here we go. The area of a rectangle is 3x squared plus 14x plus 8. And the width is x plus 4. Find the length of the rectangle.
Okay, what does area mean? Or what's the formula of area?
Length times width.
Okay, so they got a length and a width, and it gave them how much?
3.
It gave them all of
Oh.
this, right? This whole trinomial here?
Uh-huh.
Okay, it gave them 3x squared plus 14x plus 8. So they got a length and a width, and that's the answer that they got, okay? Okay, so we need to figure out what length and what width they multiplied. Are you cool with that?
Uh-huh.
Okay, we already know one of the answers, though. We know the L or the W. Which one do we know?
We know the width.
The width. We know the width. So are you ready?
Yes.
Okay, so we can do it by factoring if you want. We can factor this out, or we can just keep playing with the numbers to see which one gives us 3, 14, and 8. Which way would you like to do it?
Factor.
Factor. Here we go. So I don't know how your teacher taught you, so can you tell me how you'd set this up? Do you do the A times the C also?
Yes.
Or you're not sure?
I ain't sure.
Okay, let's do this. I'm going to go ahead and I'm going to help you out, and I'm going to set up. They multiply a binomial. A binomial means 2 terms, right? And they multiplied it by the width. Okay, if both of them are plus signs, that means my factors are probably both what?
Plus.
Plus. Okay, so here we go. They did something here times x gave them 3x squared. So what do you think that had to have been?
3x plus 2.
3x, good.
Good job.
You're going a little fast for me. So 3x times x gave them the 3x squared. So we need to figure out how they got the 8. What did they multiply the 4 to get the 8 then?
2.
A 2. Wasn't that easier to guess and play with the numbers?
I was hoping they might make some sort of a connection.
Okay, what's 3x times 4?
12x.
So positive 12x. Are we going to get the 14 in the middle?
Yes.
So we did it right. So here is my answer. Smiley face, huh? Here's another one. I'm going to put great job. It's the second time we called too, huh?
Yes.
Uh-huh. You are so welcome.
That wasn't so bad.
That wasn't bad at all.
Not at all.
I wanted to see how you were going to show her to do that problem. That was a wonderful way to show her how to do
Well,
it.
thank you.
Hey, no problem. Okay, here we go. Let's look at another problem, and we need another caller, so go ahead and call in while we are looking at the next problem.
We don't have another caller?
We have...
You guys, you need to call in. How much more time do we have? Come on, we've got 10 more minutes.
Yep, let's look at another problem.
Okay, so we're going to look at another problem. 'Cause if not, he's going to start dancing.
Yeah.
We don't want to see him dancing. Are you going to start dancing?
No.
It's that funky music. Can they hear that music too?
Okay, here we go. This is old Otis. Otis. All right, the problem reads, Otis graph.
Oh, yay.
Oh, here we go. Asia again.
Hi, Asia. Catching me drinking my coffee.
How you doing, Asia?
Hi, Asia.
Hi.
How are you?
Fine.
Sounds good. Hadn't heard from you in a little while. You ready to work a problem?
Yes.
Okay, so let's go to work. It was a joke.
I know. I'm laughing inside.
No.
Okay, here we go.
No. She wasn't joking. She was like, he's out of it. Here we go. Otis graphed the quadratic equation shown above. What is the solution of the equation that describes this function?
Okay, anytime they ask you for a solution to a quadratic, the solutions means the same thing as what?
As a quote. Roots.
Okay, roots. Give me other names that they might call them. Roots, what else?
Zeros.
Zeros.
Good job.
Yay. And one more.
X-intercept.
And the x-intercepts. Good. X-intercept. Woohoo! Okay, so those are the three different ways they'll ask you, or actually four. They'll say solution also. So this one's going to be pretty cool because they already gave you the graph. So just by looking at this, can you tell me what the roots are? Start from
Is it -4?
Yes, ma'am. This is -4
and 2.
And then 2. That was too easy, huh? Okay, just to review some other stuff, just because it's just too easy. Can you give me the vertex of this?
Is it -1 and -9?
Okay, that would be the vertex, right? So the vertex, and I didn't ask for that, but just to review, would be -1, -9. And would that be a maximum or a minimum point?
It'll be a minimum.
A minimum. Good. Awesome. A minimum. All right. So here we go. Woo, let's zoom out. So what's my final answer? We said -4 and 2. So here we go. A, B, C, or D?
B.
Awesome. Okay. How do you spell your name?
A-I-S-H-A. A-I-S-H-A.
Okay. Yay. Great job.
Wonderful job, Asia.
Okay.
Yay. Thank you, Asia.
All right. Our next caller is David from Atwell. David, are you there? All righty, David. Hey, it is so good to hear from you.
This is the second time you called?
Yep, this is the second time he's on.
Okay, David. Level of difficulty.
Medium.
Medium. Okay, medium. Here we go. That's a lot of reading, though.
It's okay. Mr. Samuel will read it.
Go for it, Mr. Samuel.
Okay. Company executives predict that the weekly profit in dollars of a manufacturing firm can be modeled by the following quadratic function. P of x equal -3.2 x squared plus 512x minus 1,000. In the function, x is the number of full-time workers employed by the company. The graph of the function is shown. According to this equation, what is the maximum weekly profit that the manufacturing firm can earn?
Okay, and keyword here would be, can you tell me?
Maximum.
Maximum. So Asia just talked to us about maximum and minimum point. So if it's got a maximum point, is it going to be a happy face or a sad face? No, Asia from the last problem talked about maximum.
Oh.
Huh?
Bad.
Okay, it's going to be a sad face. So here we go. Mr. Samuel's a little confused.
Yeah, I am totally confused.
Okay, here it is. So here is my equation. That's why it's sad, right? So the maximum point, do you agree with me, would be more or less over here? Okay, would that be cool with you? Okay, more or less would be maximum. Okay, my maximum point, is that going to be my x value or my y value? If I want my y value. So check this out. If I go under the table for this equation right here and I look under the y's, shouldn't the y be the biggest number in the table? So can I just look at the table to find the big number under the y? Yes or no?
Yes.
Okay, cool. So what is the maximum weekly profits the manufacturing firm can earn? Here we go. So I'm going to put in the calculator, okay? Let me zoom. Okay, so my equation is, let me clear this out, -3.2 x squared plus 512x, and it was minus 1,000. So how do I go to the table from there?
Second table.
Second table. There we go. So I'm going to keep scrolling down, scrolling down, scrolling down. And you tell me when you see it decrease again. There we go. We're going, going, going. Has it started decreasing yet?
No.
No, it's barely going up on the U, okay? So here we go. I'm scrolling down and okay, let's see.
Still going up.
It's still going up and oh.
Uh-oh, wait a minute.
Hold on. Okay, can you see more or less?
Yeah.
Oh, it's a little blurry. I don't know how to focus that. Okay. Let me see. Which one's the biggest number here? Let me go up a
Keep
little.
going up.
1948.
Keep going, keep going.
When did I pass it?
There it is. You did. There it is. Right.
Okay. Where would that be? Ooh, can you see that?
Yes.
I never got there. And another little clue too. What do you notice about the points above that? Can you see how they start repeating? 477, 477, 467, 467. The next one would be 451, 451. So this would be since it's a maximum point, this is the largest number that you'll find under the y-axis. If it was a minimum point, it would be the what?
It would be
This.
under the x-axis.
Oh no, the number would be the biggest number or the smallest number if it was a minimum point.
Smallest.
The smallest number. So remember this, 19,480. So let's look at my answer choices. So what would my answer be?
B.
Letter B.
Letter B.
Yay.
There it is. Wonderful job. Wonderful job.
Okay. I think, is he going to be our last caller? You didn't let me finish my smiley face. There it is. Okay.
There it
I've got
is.
my throws now. Okay, thank you for calling, David.
Okay.
Oh, you were our last caller. Save the best for the end. Okay.
Let's look at another question.
Okay, Mr. Reginald's going to dance for us. Go. You're a party pooper.
I mean, they put on the classical music to,
Classical music.
or well, what is this? This is a little contemporary,
Sounds
but
like elevator music.
yeah.
When you're in the elevator.
Oh yeah.
Or
Oh yeah.
when
This
you're
is
on
the
hold.
beginning.
when you
Yeah.
call. Like
We'll be with you in just one
I know,
moment.
and they put you on
And
hold.
then ding.
Well, our students wouldn't know that though. They don't have those.
Yeah.
Okay. Anyways,
Okay.
we're gonna go, aren't we?
We are going to go to the next problem.
Do we have another caller?
Oh, we have another problem.
Okay, I thought we were leaving. Some little bird in my ear said it was the last caller.
No, it said no more callers.
All right, we'll do one more, guys, before we can tell you who won the lucky book. Here we go. Okay, go for it. Mr. Samuel.
What is the effect on the graph of the quadratic function y equals negative 4x squared plus 3 when the equation is changed to y equals negative 2x squared plus 3?
Okay, if you guys notice, my A is the one that changed and not my C. This is my C, right? Okay, so if my C didn't change, Mr. Samuel, is it going to shift up or down at all?
You know, I would have to lean to your expertise on this problem. What do you think is going to happen?
Okay, if your C's don't change, your C tells you if it's going to shift up or down.
Okay.
Okay, but you know what? My students never remember this stuff, so I would just have them graph it in the calculator.
Okay.
So let's graph it.
Graph it.
And I would just have them compare it and see what happened from one to the other. So my original one was negative 4x squared plus 3. And then the other one was negative 2x squared plus 3. And what I like to do is have them put the first one a little bit darker because they always mess it up and they don't remember which one's the first one and which one's the second one. So they end up choosing the wrong answer.
Gotcha.
So to distinguish between the two, the darker one's the first one. So let's go ahead and graph it.
Graph the dark one. Graph the lighter one.
Okay, so Mr. Samuel, just by looking at that, did the graph shift 2 units up?
The graph did not shift 2 units up. No, it didn't.
Okay, did it shift 2 units down?
No, I didn't see it shift up or down.
You're so smart, Mr.
Hey,
Samuel.
I appreciate it.
Okay, and for a given value of x, the corresponding y value is closer to the y-axis.
Okay.
Is the y value closer to the y-axis from the first one to the second one?
You mean the x value?
For a given value of x, the corresponding y value is closer to the y-axis. The y value is closer to the y-axis. Is it closer? Look. Why did you have to show us laughing?
Okay.
Or is it letter D? For a given value x, the corresponding y value is farther from the y-axis. So which one is farther from the y-axis, Mr. Samuel? The darker one or the thinner one?
The thinner one.
The thinner one. The thinner one's the second one. So it would be letter D. Okay, here we go. Mr. Samuel, come on. Letter D. The corresponding y value is further from the y-axis.
Okay, good deal. Okay, because at first I had no clue how that question was worded.
Okay, Mr. Samuel, we'll forgive you.
I appreciate it because, thank you, yay! She gave me credit for that.
Okay.
Alrighty. Ouch.
Okay, I think that's it for today.
That's just about all the time we have for today. But before we go, what do we have to do?
We have to give away the Is the music still going on?
Yes, it is.
Oh, can they hear us talking?
Yes, they can.
Okay. Hi. Oh, okay. Now, we're going to give away the fantastic prize, you guys.
Okay, and the fantastic prize, who is the blessed caller?
Okay, we've got Asia.
Asia from Spruce. Asia, yay. Wonderful job. Okay, now remember, we would love to see you. So do not forget to bring your pictures to your teachers so that she can give them to us. And she can send them to us 2 ways, via interdepartmental mail, or she can send them to us via algebradudes@dallasisd.org.
Yeah, send us pictures, you guys.
Okay, we can't wait to see your pictures. Guys, send them. Okay.
Well, thank you for joining us today. We will see you next Monday on
The Algebra Dudes. Guys, that's all the time we have. But before we go, we always must ask this or say this statement. We don't expect you to have an understanding coming on, but we definitely expect you to have an understanding going off. We'll see you next week, guys.
Bye.
Oh, that was wonderful.
I had an excellent time. Words last night, they were cutting you off with the music.
We hope you enjoyed today's edition of The Algebra Dudes. It's been a pleasure bringing it to you. And as a quick reminder, don't forget to send in photos of yourself and your class. We love to be able to show you on TV. Either mail it to us through interdepartmental mail at DISD Box 379 or drop us a line at algebradudes@dallasisd.org. And if you want to find out more information about the show, check out our website at www.dallasisd.org/algebradudes. For all of us here at Dallas Schools Television, I'm Daryl, and we'll see you next time on The Algebra Dudes. See you then.